Hello, this is Dr. Janes, and today I'm going to talk about making variable, tunable, high voltage capacitors for the Tesla Coil. Okay, and the idea is I'm making these in a 2 half-plate type capacitors so I can slide them in and out past each other, and I'm designing them so they should hold off about 40 kilovolts. That should be good for most Tesla Coil needs. And let's get started. Okay, it looks like it finally arrived. So, I've been doing some Tesla Coil stuff, and I wanted to make some high power tunable capacitors. And let's see. So these are Plexiglass plates, I hope. Let's see how to open this. Okay, there we go. And oh, look at that. There should be something like 5 per stack. Is that right? 2, 3. Oh, I thought I ordered 10. Maybe this is not going to be enough. Okay, anyway. 5 plexiglass plates. And, yeah, I thought I ordered more of these. So I want to make some high power tunable capacitors, and so I figured these were a good size, and I'm going to get some strips of aluminum sheeting and cut them and put them in the middle of these guys, and we'll make some capacitors, some tunable capacitors. They're very clear, so you can see right through them in the center like that. Okay. It should be very interesting. Yeah, I have enough to make several of them, although I think I miscalculated. I think I need to get some more because I want more capacitors. Okay. And we'll see how this works out. Hello, this is Dr. Janes, and today I'm going to talk about how to build a tunable stack of high voltage capacitors. This one is going to be rated for about 40,000 volts, I'm going to say. Could be higher. Depends on what values you pick for the breakdown voltage of plexiglass. And simple to build, and I'm going to show step by step how to build these guys and test them at high voltage. And this stack is about, I think, 350 picofarads. Anyway, so let's get started. Okay, hello, this is Dr. Janes, and today we're going to talk about making tunable high voltage capacitors for Tesla coils. So I'm going to use a few things. I have a hot glue gun. Hot glue is nice, it dries quickly, and it's not going to be required to hold off the voltage. So I just want a mechanical bond. I have a paper cutter here, so I can cut my strips of aluminum, and I ordered a bunch of plexiglass pieces that were the right size. It's easier to order them, I think, than it is to cut all these by a big piece. And so, here, 5 by 7, and of course it has the paper on them, so I'm going to take off the paper, and well, I think this will be about the right size. I think this is 6 inches wide, and so I'll just use the paper. Paper cutter's nice. It cuts aluminum sheets, aluminum sheeting. I got this from Home Depot, I think. Very straight corners, and when you cut it with the scissors, it has wrinkles and ripples and stuff. And so this device will cut it quickly. It has a let's take a look here. Okay, I'm just peeling off the paper on one of these so we can take a look at it. But this is going to be our capacitor plate, and it's about 2 millimeters thick. And I was doing some research on what kind of voltage this will hold off, and I'm estimating, they give you different numbers depending on what kind of plexiglass it is and other things, but it's probably about 10 kV per millimeter. And I'm going to have 2 millimeters here thickness on one side and 2 millimeters on the other side, so we'll have about a total of 4 millimeters. So we should be able to hold off about 40 kilovolts of voltage, which should be good for our Tesla coil. And again, this is a 5x7, and I believe this is 6-inch flashing. So I'm going to leave a half an inch on either side. I don't know if you can see. I should have left here's one with the coating on it there. So there will be about a half an inch on either side, so the voltage won't be able to go around it. You won't be able to get an arc. So that should be enough to hold off the voltage. And what I'm going to do is I'm going to build these in 2 halves, so I can slide the halves past each other and change the capacitance. Once I get it in the spot I want, I'll probably just tape them or glue them together. So it'll be a tunable high voltage capacitor that you can set in place once you got it tuned up to your coil. If you need more, you can stack them one on top of the other like that to get higher capacitance. So let's take a look at this guy. Okay. So here's our aluminum flashing, and let me just roll some out. I'm going to get it lined up on the edge here. That'll make it square. And unfortunately, when these cutters get a little bit older, let's take a look here. I have to kind of push in like that as I bring it down. You don't want to get your fingers under there because you don't want to cut your fingers. I'm going to cut off this edge because it's a little bit crooked. I think I cut it with scissors before. Okay. And see that? It cuts a nice sharp flat edge there. And let me start measuring these out. I'm going to measure them out. Let's see, this is a 5x7. I think I'm going to cut it 5 inches and leave a half an inch overhang out the edge so that I can hook wires onto it or something. And that should be good. So we'll just make these pieces 6x5, and we'll test that out and see how that looks. Okay. Okay, there's actually a ruler along this edge, but I think I'm just going to take one of these sheets and just mark it here on the aluminum foil where I want to cut it, like so. And we will feed this up, make sure it's flat along this side, and chop her off. Okay, and there's our square sheet. Let's zoom out a little bit. Okay, so this is the idea. We'll have one of these. I'm going to peel off the tape on it and leave about a half an inch around the edge like so. Then put another one on top, and this will provide insulation between this and the next capacitor. And let me go ahead and I'll cut a couple more of these aluminum pieces because I think they're a good size, and we'll build some capacitors with them. Okay. Okay, let's keep on marking them out, like so. Chopping them off. Okay, 8. And I'm going to make a few of these because I have lots of projects that I'd like to use these for. And we'll just crank out a few of these and see how this works out. Okay, so here we have a hot glue gun, and I've been warming it up for a little while. And a couple plates. I know it's really hard to see these. And our aluminum plate, which I'm going to sandwich in between like so. And I think I'm going to I'm not sure exactly how I'm going to do this. Maybe I'll go around the outside, try to glue this in place, and then sandwich the other guy on top of this, like so. Oops. Here's my next glue stick. Okay, got another glue stick in there. Before this thing dries, may have to reheat the other side up. Okay, let me get the other plate on top while that's still hot. And there we go. I think that might be good. If not, we'll have to put some more glue on it. Okay. Maybe I'll glue around the edges to make sure it's mechanically strong. And so the idea is we'll take one of these. Let me just glue it along here. Glue it along the front edge. Okay. And I'll glue it on the other side. I don't really want the glue to get on top because I don't want a gap in there. I want this to be a reproducible distance. So you can always scrape that off afterwards. And so there is a half plate of our capacitor. And what I'll do is I'll put the high voltage of one polarity on one side and then high voltage on, well, let me just get the second plate and we'll take a look at this. Okay, so there's another piece of Plexiglass. Find one more. Okay, so here's our second half capacitor, and I'll get it lined up so it's about a half an inch around each edge, and we'll glue this thing down as quickly as we can. It looks like I should have got another glue stick ready because it's really going through the glue sticks. Come on, get it. Okay. And let's get that top plate on there. Well, it's still hot. And again, I think I'm going to glue on the front a little bit here to give it more mechanical strength. And flip it over and glue here too. Okay. So now I have two half plates, and you can stick them together like this. And so the high voltage of one polarity will be on this side, and the high voltage of the other polarity will be on that side. And I don't know if you can see this very well, but it would have to go, since there's a plate on the top and the bottom, it'll have to go about a half a centimeter out, around, and back. And so if you're only running at 40 kilovolts, which is what these are going to be rated for, it will not be able to travel this distance and break down around the edge. Okay, and then you can make these variable by sliding them like this, so they have very little overlap, to maximum overlap, which should be about there. And I might go ahead and drill some holes and put some wires on here so I can hook it up to a normal circuit, but we can test these with clip leads at first. Okay, let me go ahead and make a few more of these while I'm working on it, and we'll test these out and see what kind of capacitance they have and tune them up, maybe put them on the coil. Okay. Okay, so here I have two of the half plates. See, just setting one on top of the other. And I have it hooked up to our universal LRC meter. And it's telling me that it's about 11 picofarads. And I think I estimate I need about 30 or 40 picofarads to tune up the coil. Oh, maybe it's too low of a farad to actually measure. Oh wait, there we go. Something happened. Maybe we're not getting good contact. Oh, okay, there we go. I guess the clip leads are not making good contact. There we go. So, yeah, because it wasn't responding at all. Look at that. So 85, 62. So the idea is that if you slide this plate over a little bit, the capacitance should go down. And if you slide it back, right, the capacitance should go back up. So I guess when I'm touching it, the capacitance goes way up or something, but okay, let's get our hands off of it. So about 60, 65 picofarads, 59 picofarads there, and then I'll slide it over a little bit, and we'll see what it is. Now it goes down to 40, and let me just move the meter over a little bit so we can slide these further apart. Okay, and so I think it has lost contact again, maybe. These clip leads are not the greatest. Okay, there, so about 30. So about 30 picofarads in that position. And so the idea is that you can just, whenever you want to tune up the coils, you can slide these plates back and forth until you get the optimum tuning, and then maybe just tape them in place or something, or maybe you could glue them eventually if you want them to be solid. Maybe remake smaller ones if they're way too big. So let's see if we can make this go a little bit lower. Okay. Okay, so that is, oh come on. I guess the clip leads aren't making good contact. I'm going to have to put some copper wires onto it and solder them. I'll probably put a hole through it and loop them. Okay, so 19. And again, I'm just going to move it back up so you can see that as I slide it over, okay, so that they're on top of each other, we get about 60 picofarads. Okay, so I think this should be plenty of range to tune up my Tesla coils, one per coil, and I'm going to make some other ones for other things, and this should be very interesting. Okay. Okay, so I got my plates here, and I got a drill, and I think I'm just going to put some wood backing so I can drill into that. I'm just going to drill some holes in the corners, I think, so I can run some wires through, loop it through, and solder it to itself, because it's really not easy to solder to aluminum. So I'm going to have to solder the wire to itself. Okay. Let's take a look here. Okay, so there we go. I have a hole in our capacitor plate, and I think I'll do the rest of them like that, and we'll just solder some wires onto them so they're easier to... Remember, aluminum forms an oxide layer, so it's not easy to solder to. You need special brazing materials or special alloys to solder to it. And it's that oxide layer, I guess, you know, earlier I was trying to test it with clip leads, and I think that was playing havoc with the clip leads also, because aluminum forms the oxide layer very quickly. So this putting some copper wires on it should fix that problem. Okay, so here we have some enameled wire. I think we're going to use that. I cut off a strip, and here's our hole, and I'm just going to feed some through, and let me do this. Hold this in place. Okay. So I'll feed this wire through like so. And I stripped it back quite a bit here because I'm going to twist it onto itself like that.
because we're going to need to solder this to itself to get, in fact, I might need some pliers to tighten this up, because we're going to need a strong, tight mechanical bond here. Tighten that up very tight without breaking it, of course. Let's crush this, because we're going to have to probably run solder through that hole and see if we can get a mechanical bond just to the copper, and hopefully that will give us a good bond to the aluminum. Okay, get this a little bit tighter. If you twist it up too much, it's going to break. I'll crimp this thing down, because it's going to be hard to solder to this aluminum. Okay. Okay, so here's where we twisted it up. We're going to solder this wire to itself, and I'm going to try to do this with one hand. Two hands, I guess. Okay, there. So we got that tinned up like so. And let me try to get a big glob of solder through this hole up here onto the copper. It will bond to the copper. It will not probably bond to the aluminum. Let's see if we can just glob that up so we can kind of braze this all together. We'll see what we can do here. See, it's not sticking to the aluminum. I'll try to get some on this side and put some on the other side. See if we can get a big, well, that piece is kind of sticking. But it's really going to stick to the copper, so you need it to alloy to the copper. Okay. Flip this guy over. And try to get some on the other side as well. Make a nice glob over here. So it will have a mechanical bond, if nothing else, on both sides. Okay. Okay. Oh, come on. Okay. Let me get a little more solder out of here. It looks like it might be forming a good bond down here now. It's okay, there we go. There's solder there. Oh, come on, just form a good bond there. Okay, we'll see. We got a bunch of solder through that hole on both sides, so we'll see if we can get a good bond with that. I'm going to fiddle with this for a second. Okay, so it looks like, see, I'm wiggling the wire here. It looks like it's pretty strongly bonded. I'm going to test it with a voltmeter and make sure that we got good continuity too. Okay, and if so, we can continue soldering up the rest of these plates like this. Okay, so I have my voltmeter hooked up. I have one clip lead. Well, had to wiggle it kind of to get through the oxide layer. And let me just clip this onto the other side, like so. And there we go. It looks like we have good continuity. So this solder joint we made here has a good bond, and I think we're all set to start making more capacitors. Okay. Okay, so I'm going to try to find the resonance. I have two half plates here of our capacitor. Okay. And I have a coil here for primary for my Tesla coil. And I have it hooked up my signal generator, and I'm just going to twiddle the knob, twiddle the frequency, and try to find the maximum here. Oh. Okay, my scope keeps on going out if you don't. I don't know how I can set it for a longer time period. Okay, I brought it all the way up, so there is 1 megahertz. Okay, so this is already going to be a higher frequency than what I want. I'm going to bring the scale up to the 10 megahertz setting, and we will see where we are there. Okay, so it looks like the maximum occurs around 3 megahertz. So we're going to need more capacitors, I think, more capacitor plates. And oh, by the way, I put a resistor in series with the drive voltage of this guy because I wanted to decouple this tank resonator from our drive circuit so I could get a better measure of the resonant frequency. So it looks like we're about at 3 megahertz right now with two half plates. Okay, so I'm going to try to add some more half plates and see what happens. Okay, so here I added another second half plate, so there's a total of 3 half plates. And it looks like our frequency now is around, the maximum is around 2.4 megahertz, so it's still way too high. So I'm still going to need bigger capacitor. Okay, let's keep on tuning it. Maybe I'll have to make a new primary or something, because I really didn't want to use that many capacitor plates. Okay. And again, I just wanted to mention I am using a sine wave setting, because square wave will have a bunch of harmonics, so I don't want to, I want to make sure I have the right frequency. Let's see, is this thing? Okay, it seemed like it wasn't in focus. Okay, so there, I think that's about the maximum. It still seems to be pretty high. Let me fiddle with this some more. Okay. Okay, make sure the scope is... Okay, so let me twiddle with this some more. And I think... Okay, there. That might be about the maximum. Well, it seemed like it was a little bit lower. There. Okay. 1.7 megahertz. So it's still a little bit higher. I might just take some measurements of these plates and see what I think they should be. See what I think the resonant frequency should be. And anyway, it's definitely tuning the frequency down, but it's still way too high. So worst case, I may redesign the primary of the Tesla coil and put a lot more windings on it to bring the inductance up. Okay. Very interesting, huh? Okay, so I have about 7 half plates, which is what I had enough to make from the Plexiglass that I got. And it's measuring about 354 picofarads. Okay. And I'm going to measure the inductance of our primary coil here and see what that is, and then I'll do some calculations and see if that's the resonant frequency that I expect. Remember, we're measuring up on our meter here with our little oscope about 1.7 megahertz, which is a lot higher than the resonance I'm looking for. I think the coil had a resonance of about 270 kilohertz or so. Yeah, okay. So 354 picofarads. Okay. Okay, and it looks like this coil right here is about 11 nanohenries. So let me do some calculations and I'll see if everything works out the way I expect it should be. Okay. Okay, so this is literally a back of the envelope calculation. 11 microhenries for the coil and 354 picofarads for the 7 half plates I made here. And if we do the calculations, well, let's look at this again. Frequency is 1 over 2 pi the square root of L times C. Okay. And I just put it in the spreadsheet so I don't make mistakes, hopefully. It's saying about 2.5 megahertz. So that's in the ballpark of what we were measuring. I could have been off a little bit when I was twiddling the knob. So, or these meters could be off a little bit, but yeah, I guess that is the case. And so, since I don't want to have a huge stack of capacitors, I think I'm going to try to redesign the primary. It'd be a lot easier to make a bigger primary, higher inductance primary, and use that for the Tesla coil, and then we'll try to tune in the resonance to that. Should be interesting. Okay, again, here's an insanity check. Some people call it a sanity check, where I just disconnected the top plate, again, because I didn't go through all of them, and the capacitance went down to 303. And let me disconnect another plate. Okay, oh, just one more plate. And now it's 241. And I could disconnect another plate from over here. Okay. About 200. Okay. And maybe disconnect one more plate over here. $138. Disconnect one more plate over there. So I just got 1 and 1, and so 76. So it's about 76 picofarads per plate. Okay. So I think that we're definitely going to do a redesign of this coil, and I'm going to make a much higher inductance coil. And I think we should be good to go then. Okay, so we've tested out these capacitors to show that they're tunable. Let's just check that they're work at high voltage, okay? And this is a device that I show how to make in one of my other videos, and this is a Chinese multiplier, and they claim it's a 40,000 volts. No, it's 400,000 volts or something. No, I guess it's 100,000. It's something ridiculously high. But I tested it, and it's about 15 kV, something more reasonable, something you'd expect from something this size. But it's a pretty nice device, and of course I put a battery on it and a switch, and I showed how to do that in one of my videos. So let's charge up our capacitor with this thing, and okay, and then we'll discharge it and see how this thing works. Okay. Again, I guess that's probably what you expect from about 300 and some picofarads. Definitely holds electricity, right? Charge it back up again. Okay, it's holding off the voltage for sure. This is at least 15 kV. And it definitely stores the voltage. And so these should be good for tuning up Tesla coils. I'll try one more time. Okay. So there we go. And this is 7 half plates, is what I said before. And definitely working as a capacitor, a high voltage capacitor, holding off the voltage. Okay. Okay, very interesting. Anyway, high voltage capacitor stack, tunable for your Tesla coils, and should be interesting. We'll have to try this out. This is Dr. Janes, and thanks for watching.